All right, so in this lesson, we are going to graph the solutions. Remember, solutions are points with an x comma y, so we'll put points. So we're going to graph some points, some solutions of a linear function given in slope-intercept form. So we're going to graph points of a line. This is a line given in slope-intercept form. Before we can do that, before we can graph these solutions in slope-intercept form, we have to know what slope-intercept form is. So slope-intercept form is y equals mx plus b. Now m is going to be our slope, also known as our constant rate of change. And this will be how we move. And the plus b, let's use, I guess, green. The plus b will be something called the y-intercept. The y-intercept. I don't know why I can't get that to look right. The y-intercept. Guess that's better than nothing, right? The y-intercept. This, a lot of people think about as where we start. It's where we start. I don't know why that bothers me. Oh, there we go. I think I got it. So the y-intercept is where we start. It's also where the graph crosses, or yeah, where the graph crosses the y-axis. So crosses the y-axis. So the y-intercept, a lot of people think of as like where we start. It's useful to think about it as the starting point. But you can also think about it as where our line crosses the y-axis. So let's graph some slope-intercept forms. So y equals 1/2 x plus 3. We know that the 1/2 is the m, and the plus 3 is the b. So let's figure out where we start, which is the y-intercept. So we start at positive 3. So 0, positive 3. So we go to 0, positive 3. This is where we start. This is our y-intercept. It crosses the y-axis. And then our slope is 1/2. More specifically is positive 1 over positive 2, which means you go up 1, right 2. So up 1, right 2. Oop. Up 1, right 2. Up 1, right 2. Let's go back. Oh, let's do it one more. Up 1, right 2. And we can go backwards, down 1, left 2. And so on and so forth. So these are just 1, 2, 3, 4 solutions. But we have a bunch more points. They just keep going, and we have some decimal ones. So what we do is we use these 1, 2, 3, 4, 5 points. You don't need 5, you can use 3, or 4, whatever, as long as you have more than one. We use these to help us draw or represent the rest of the dots. So we know that the rest of the dots fall kind of like this line right here. I'll do it one more time. Okay, so we use these 1, 2, 3, 4, 5 points to help us draw a bunch more, like dot 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 dot, and we show that it keeps going. I'm going to draw this a little. All right, let's do it again. So once again, we know that this 2/3 is the m, and this -4 is the b. So the b is a -4. So instead of being 0, +4, it's going to be 0, -4. So we go to our y-axis. We go 1, 2, 3, 4 down. And that is our y-intercept. We can see that our slope is 2 over 3, more specifically +2 over +3. That means we go up to right 3, up to right 3, up to right 3, down 2, left 3, down 2, left 3. And we're technically to draw this line somewhat accurately, we only need 2 points, because if we go through these two, we'll go through the rest. But draw a couple going forward, a couple going backwards, and we'll be fine. So here's one of the points I found. Here's another one. Here's another one. Here's another one. Now let's go ahead and try to represent the rest of them. Now remember, oh, I almost came so close. That's close enough. Now remember that I only drew 1, 2, 3, 4, 5 points, but they're a bunch of decimal ones, and they keep going like this way and that way. All right, example number 3. So -3 over 4 is our slope. -2 is our y-intercept. It's our b. So -2, so it's 0, -2. 0, -2, that's where it crosses, the line crosses the y-axis. That's why it's called the y-intercept. And my slope is -3 over 4. So I'll just write it first. So -3 over 4. Now, you might be tempted to put a negative down here also. Like make the 3 a negative and make the 4 a negative. But if they were both negative, we would have a negative over a negative, which would make this 3 over 4 positive. But it's not a positive 3 over 4. It's a negative 3 over 4. So if both were negative, it'd be negative over negative, which would be a positive. And that's not a positive. So only one of these numbers can be negative. For our purposes, let's make this top one negative. So -3 over +4. So we go down 3, right 4, down 3, 2, 3, right 4, 1, 2, 3, 4. Down 3, 1, 2, 3, right 4, 1, 2, 3, 4. And then up 3, 1, 2, 3, 1, 2, 3, 4. And that'll be fine. So we graphed my y-intercept first, and then we use our slope to find more points. Let's see. So, and let's do our best to connect these. So not too bad so far. Not amazing, but not too bad. So we graphed 1, 2, 3, 4 points, 4 solutions for this equation. And then we use those points to draw the rest of the dots for this. Don't forget that all of these xy's, xy, 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 all these points, they all have an xy that will make this equation true. All right, example number 4, -2x, y equals -2x. So we know that -2 is our slope, is our m. But if you can tell, there's nothing over here for the b. There's nothing over here for the y-intercept. So we just put +0. Technically, you can put -0 because +0 -0 doesn't make a difference. So that means our y-intercept is 0, 0. So 0, 0, that's where it crosses the y-axis. That's where our line crosses the y-axis. Our slope is -2. But remember that we have a denominator and it's 1, so, and only one of them can be negative. So plus 1. Only remember, only one of them would be negative, because if both were negative, it would be a positive 2x, and that's not what it is. So we go down to right 1. So down to right 1. Down to right 1. Up to left 1. Oh, I guess I should. Up to left 1. Up to left 1. And so we graphed our y-intercept. And then we graphed, or we used our slope to find some additional points, additional xy's that make this true, this equation. So let's represent the rest of the dots. Going upper right, downward left is very difficult for me. Okay. That'll have to do. All right, 2 or more. So we have our slope should be here. And remember, if there's nothing in front of the x, if there's no coefficient, it's a 1x. And then we have our y-intercept, which is -4. So 0, -4. 0, -1, 2, 3, 4. Okay, and then my slope is 1, but that would be 1 over 1, so positive 1 over positive 1. So we go up 1, right 1. So, trying to make this easier for people that look at the notes. Okay, so primarily look at the notes. So up 1, right 1. Up 1, right 1. I keep doing this, but it's just so close together. I'd rather not. Down 1, left 1. Down 1, left 1. So we started with our y-intercept. And then we used our slope, up 1, right 1, to get more points, more additional points. Okay, so let's use these points to draw more points, to represent more points. Oh, so close. I don't know why this one in particular. Good enough. Oh man, okay. Let's do it like that. Better. So, last example, y equals -x plus 5. Remember that if there's nothing, no number, no coefficient here, it's actually, there is one. It's -1 over 1. And my y-intercept, well, let's back up. That's m. My slope, and my b, which is my y-intercept, is 0, 5. So 0, 5. So let's go to 0, 5, 0, 1, 2, 3, 4, 5. This is where my line will cross the y-axis. And I will go down 1, right 1. Down 1, right 1. Down 1, right 1. Up 1, left 1. Up 1, left 1. Oh, let me chill out with that first. Forgot to show you. -1. -1 over +1. And that means we go down 1, right 1. So now we can do it. Down 1, right 1. Down 1, right 1. Up 1, left 1. Up 1, left 1. All right, so we started with our y-intercept. And then we used our slope to find additional solutions. And we will use those additional solutions to draw even more solutions, to represent even more solutions. Okay, that one's fine, I guess. No, it was fine to the end. Okay, let's try it. All right, cool. And so basically all we did, just as a quick reminder, is we use our slope-intercept form, which is y equals mx plus b. And we took equations, these equations, in slope-intercept form, and we graphed their solutions. So we took these equations and we graphed solutions using the slope and the y-intercept. And that is it. Thank you.